Hey guys, welcome to the second video. This video is going to be based around energy systems of our body. There are three energy systems and their job is to create energy for our bodies to move. The way we do that is our bodies convert chemical energy from the food that we eat into movement energy. There is a molecule in our body called ATP, which stands for adenosine triphosphate, and this molecule is in the muscles, and this is what causes our muscles to move. The issue is that our muscles only have very few, very small amounts of ATP stored. So once it uses this very short amount, which is about 1 to 2 seconds, then our body needs to then produce more ATP. And it does this in three different ways. We have two anaerobic energy systems, and the reason why they're called anaerobic is because they don't use oxygen. And I'm going through this in this order because this is usually the first energy system that's used. We're going to watch a short video first about the ATP-PC system, and it'll explain it a bit more.
When our body has to perform powerful, explosive movements, it calls on the ATP-CP system. CP stands for creatine phosphate. This compound, which is stored in the muscle, is the main fuel for the ATP-CP system. The ATP-CP system works by first using up the ATP in our muscles, then by breaking down creatine phosphate to give energy for ATP resynthesis. This system produces ATP very quickly, but the downside is that it runs out of fuel in around 10 seconds. So this is the main energy system for short-term, high-intensity effort.
Different swing altogether.
Okay, so that was the video on the ATP-PC system. So now what I want you to do is if you go into your booklet, okay, so it should look something like this, and I want you to just scroll down a little bit, and it's got a summary of the three energy systems. Now there's a few things that we're going to fill out. If you have a look at fuel, there's a missing area for the ATP-PC system, and I want you to write down what is the fuel source for the ATP-PC system. Hint, it's in the name. So what is the fuel that is used to basically allow that system to produce energy? Okay, so once you've written that down, if you need to pause the video at any time, please do so. The amount of energy that's supplied is very limited, okay, only about 10 seconds. It's used for things between 95 and 100% maximum effort. So think about things like you saw in the video, long jumper, serving in tennis, a volleyball spike. They last between 10 to 12 seconds, a very small amount of time, but it's very intense. Now, what causes the fatigue of the ATP-PC system? I'm not sure if that was on the video, and basically what it is when the creatine phosphate, or the CP, runs out. So if you want to write that into your booklet, when it runs out. Waste product, there aren't any waste products, which is great for the body, and it takes around 30 seconds to 2 minutes to recover. So if you think about that, you can do a long jump, and you can have a few minutes rest, and then you can go and do another long jump or a high jump, whichever the event is. Same with shot put, discus, javelin. You could even do a 100-meter sprint, and you could technically go back if you were trained enough to do it again. So energy system is the ATP system. I want you to write down some sports that are in that system. Okay, we're going to watch another video now, and this video is on the anaerobic energy system, and the second one, which is called the lactic acid system.
The lactic acid system can provide energy for longer than the ATP-CP system because it uses a more abundant fuel. That fuel is carbohydrate in the form of glucose. Glucose circulates in our bloodstream and is also stored in muscle and liver cells as glycogen. In the lactic acid system, glucose is broken down without oxygen to give energy for ATP resynthesis, plus the byproduct lactic acid. As in the ATP-CP system, energy is produced quickly, but the buildup of lactic acid causes fatigue, which we feel as a burning sensation in the muscles. The more intense the exercise, the faster the onset of fatigue. This limits the contribution that the lactic acid system can make. So during intensive exercise, the lactic acid system dominates from about 10 seconds when the ATP-CP system is depleted, up to a maximum of about 3 minutes, depending on the intensity of exercise. In sports played over longer periods, the lactic acid system is important for supplying energy quickly during intensive phases of play.
Okay, so that was the second energy system, which is the lactic acid system. And in your booklet, sorry, on the wrong page, if you have a look at your booklet, there should be the same thing. So we're looking at the fuel, which is carbohydrates broken into muscle, glycogen and glucose. The amount of energy supplied, so it is still limited. Okay, it's definitely not very limited, but it's definitely limited, and it lasts for about anywhere between 30 seconds to 2 to 3 minutes. So think about sports that usually lasts for. So think about a 200-meter sprint, or even maybe a 400-meter sprint. The cause of fatigue, it says that it's a buildup of lactic acid. And what is the waste product? So I've just given you a hint there with what I've just said. So I want you to write down what you think the waste product is of lactic acid. You can always go back and watch the video again. And it takes about 20 minutes to 2 hours to recover fully if you've been using the lactic acid system. So if you've done a 400-meter or an 800-meter run, depending on how quick you do it, it will take somewhere between 20 minutes and 2 hours to recover. And I want you to write down what sports you think the lactic acid system is used for. Think about sports that go for anywhere between 30 seconds and 3 minutes. Not many sports, but think about something within the sport that might go for that period of time. Okay, now we're going to watch one more video, and this video is actually on the aerobic system, which is the final system of our body and tends to be the one that is used most often.
When the body requires a more sustained supply of energy, it relies on the aerobic energy system. This system works by breaking down carbohydrate, fat, and sometimes even protein in the presence of oxygen. This produces large amounts of energy for ATP resynthesis, plus carbon dioxide and water. Unlike lactic acid, these byproducts are not harmful to performance. For the aerobic energy system, fatigue is a result of running out of carbohydrate. Although fat can be used as a fuel in this system, we start to feel tired when our glycogen runs out. Our glycogen stores can last for several hours, depending on how hard we're working. In the well-trained athlete, the body mixes glycogen and fat as the source of fuel, so the glycogen supply lasts even longer. This is called glycogen sparing. The aerobic energy system is the main source of energy in middle distance events and in endurance sports, such as triathlon and marathon. In many sports, the aerobic system is also important for endurance and recovery in between bouts of intensive activity. While the aerobic system dominates, lactic acid is cleared from the muscles, and the fuel reserves in the muscles are topped up.
Okay, so that's the last video on the energy systems, and that talked about the aerobic energy system and how it's used in our body. So if we have a look at the fuel source, okay, carbohydrates and fats, energy is pretty much unlimited if it's at a low supply. So while you're sitting at the computer, you're using your aerobic system, okay? So the aerobic system, although, it can last, maybe between 1 to 2 hours when it's somewhat intense, or even up to 6 hours long. So think about a marathon that goes for about 2 hours, but if you're playing, you're riding your bike during the day up and down, that could go for 3 or 4 hours. So it depends on the intensity. Okay, the aerobic system basically will stop when your carbohydrates and your fats runs out, which is fairly unlikely if you can make sure that you eat regularly. The waste products are carbohydrates and water. Carbon dioxide and water. So they're waste products that are safe for the body. The recovery time. So this can be, depending on the intensity of the activity, up to 24 hours. So think about someone doing a marathon. That would take a long time for them to recover. And I want you to write down some sports that use the aerobic system. Okay, so that's going to be where we stop our next video.